Oops, sorry about that. Chapter 4.3, multiplying monomials. Very similar to 4.1, where we know how we're multiplying like terms. And one of the rules here about multiplying like bases is that when we multiply like bases, we are going to add their exponents. And let's go over that. Let's take, no, let's not take m because we already have an m. Let's take x to the third times x to the second. Because they have like bases, we are going to add their exponents. That's x to the 3 plus 2, or x to the fifth. If we think about this logically, x to the third is x times x times x times x to the second, which is x times x. So if we had to write this using exponents, that would be x to the fifth. And all we're doing is we're taking 3x's multiplying by itself times 2x's multiplying itself. So if we have 3 times another 2, we have a total of 5. So that's why we add those exponents. Now, I like this important thing right here. This is a good caution. When they are not like bases, we cannot combine them. So this is the answer. This is just the answer. M squared times n cubed is just m squared n cubed. You can't combine those. Those are not like bases. We can only do like bases. Those have like bases, so we're going to add their exponents. We get x to the seventh. Like bases, add their exponents, c to the ninth. Like bases, add their exponents. There's a 1 in there, so 1 plus 5 gives you 6. Okay, so x to the 3 plus 6, or x to the ninth. C to the 7 plus 8, or c to the 15th. A to the 9 plus 10, or a to the 19th. Yup, that easy. X to the 2 plus 3 plus 1. So remember there's a 1 there, which gives us x to the 6th. N to the 2 plus 2 plus 3. We can do as many, we just add those exponents, and that's n to the 7th. N to the 7th, Mr. Mac. C to the 1 plus 5 plus 2, c to the 8th. A to the 2 plus 3 plus 5, a to the 10th. X to the 5 plus 6 plus 7, which is x to the 18th. C to the 3 plus 6 plus 7, which is c to the 16th. M to the 2 plus 6 plus 8, m to the 16th. N to the 10 plus 1 plus 3, n to the 14th. X to the 1 plus 9 plus 10, x to the 20th. All right, so now when we have monomial times monomial, we are going to multiply their coefficients, 2 and 4. And now, since we have like bases, we're going to add their exponents. So that gives us 8x to the 7th. So we have 2 times 5 times a to the 4th times a to the 3rd, which is 10, a to the 4 plus 3, which is 10, a to the 7th. We have 4 times 3 times x to the 3rd times x to the 4th, which is 12x to the 3 plus 4, which is 12x to the 7th. 7 times 2 times m to the 5th times m to the 6th, which is 14m to the 5 plus 6, or 14m to the 11th. 5 times 3 times x to the 4th times x to the 2nd, 15 times x to the 4 plus 2, which is 15x to the 6th. -2 times -3 times x squared times y squared times y. That's going to be 6 times x to the 1 plus 2 times y to the 2 plus 1. 6x to the 3rd, y to the 3rd. we have 4 times negative 3 times a squared times a times b cubed, which is negative 12 times a to the 2 plus 1 times b to the 1 plus 3, negative 12a to the third, b to the fourth. 3 times 1 times 5 times a squared times b times b squared. That's going to be 15 times a to the 1 plus 2, b to the 1 plus 1 plus 2, 15a cubed, b to the fourth. We have 6 times 2 times 3 times x squared times x times y squared. That's going to be 36 x to the 2 plus 1 plus 1, y to the 1 plus 2, 36 x to the fourth, y to the third. We have 3 times negative 2 times 4 times c. I know what you're asking. You're asking, how could students be coming into the classroom, into the homeroom at 2:35? Shouldn't they be in class? I know. I don't know what they're... You just want to be on the video. C times c squared times c times d to the fourth times d squared, which is negative 24c to the 1 plus 2 plus 1 times d to the 4 plus 2. Those silly students. Negative 24, c to the fourth, d to the sixth. 5 times negative 4 times negative 2 times a to the third, a squared a times b cubed. That makes 40, positive 40, a to the 3 plus 2 plus 1 times b to the 2 plus 2 plus 3. 40, a to the 6th, b to the 7th. Whoa. Negative 1 times 3 times negative 4 times x to the second, x times y to the second, y cubed. That's going to be 12 x to the 2 plus 2 plus 1, y to the 2 plus 1 plus 3. 12 x to the fifth, y to the sixth. That's negative 1 times negative 5 times negative 1 times a squared times a times b cubed times b squared. That is negative 5 a to the 2 plus 1, b to the 1 plus 3 plus 2, negative 5 a to the third, b to the sixth. Oh baby, division. Okay. Division. So we're going to still deal with our coefficients and then deal with our variables. So we have 3/4 times 4/3. And then we have r squared and t squared. Those are not like terms, so we're not going to add those exponents. But we will deal with the coefficients. When they're whole numbers, it's easy. When it's fractions, technically, it's just as easy. So we get r squared, t squared, because this produces 1. When they cancel to make 1. So coefficients, 6/5, 20/3. Now let's deal with the variables. H to the second, h, k to the third, k squared. So let's do this. This becomes a 2. This becomes a 4. 2 times 4 is 8. H to the 2 plus 1, k to the 3 plus 2. So 8, h to the third, k to the fifth. Just as easy. Fractions didn't make it any harder. 8 times 3/4 times a squared. 8 becomes 8 over 1. The 4 cancels in the denominator with 8 in the numerator. 2 times 3 is 6. A to the 1 plus 2, or 6a to the third. We can do it just as fast. We have 12 times negative 5/6 times c squared times c times d squared. This 6 in the denominator is going to cancel with the 12 in the numerator. 2 times negative 5 is negative 10. C to the second plus 1 times d to the second. That doesn't have a partner. Negative 10 c to the third d squared. 3/7 is the coefficient. 35 is the coefficient. A squared times a to the 5th. The 7 in the denominator cancels with the 35 in the numerator. We get 15, a to the 2 plus 5, 15a to the 7th. Coefficients, 8 over 5, coefficient 15 over 16, times x squared times x, y times y squared. These are in the numerator. So 8 and 16, 5 and 15, we get 3/2, x to the 2 plus 1, y to the 1 plus 2, which gives us 3/2, x to the third, y to the third. Or, here's a nice little high school answer, x to the third, y to the third over 2. We can put all the numerators together in the numerator. This is in the numerator. This is in the numerator. So you'll notice that I put it all in the numerator. The 2 is in the denominator. It's the only thing in the denominator. Coefficients, negative 5/6, 3, negative 1. Let's deal with our variables. X to the third times x. We have y squared times y squared. The 6 in the denominator will cancel with the 3 in the numerator. That gives us negative, not negative, because the 2 negatives make a positive. So 5/2, x to the 3 plus 1, y to the 2 plus 2. We get 5/2, x to the 4th, y to the 4th, or 5x to the 4th, y to the 4th over 2. Both of those answers are okay. Coefficients, 3, 2/3, 1/2. No x's, so we'll go straight to the y, y to the second, y to the second, y. 3 in the denominator cancels with 3 in the numerator. 2 in the denominator cancels with 2 in the numerator. We're left with 1. We have y to the 2 plus 1, which equals y to the 5th. We wouldn't write a 1. Coefficients of ones are not written. All right, so this is more of an orders of operation. We're going to do this product, and then we will add. So we're going to multiply, get 2 products, and then we will combine them. Then we will add. So like terms, oh, isn't that interesting? Forgot about writing this thing. Like terms, yes. These are all like terms. These are not like terms. So very important to see the difference between like terms and not like terms. So let's multiply this. We have 2 times 3 times x cubed, which is 6x to the 1 plus 3, or 6x to the 4th, plus, let's do this. This is going to be 5 times 4 times x squared, which gives us 20x to the 2 plus 2, or 20x to the 4th. Those are like terms, so we're going to combine their coefficients, and we get 26x to the 4th. Notice the variable stayed as x to the 4th. We did not add their exponents because we're not multiplying them. At that point, we're just adding, and we just add their coefficients. So we have 3 times 4 times x to the 5th times x, which is 12x to the 5 plus 1, or 12x to the 6th. We have the opposite of 5 times 2 times x to the 3rd, which is negative 10x to the 3 plus 3, or negative 10x to the 6th. Those are like terms because they have the same variable to the same exponent, so we will combine their coefficients. 12 and negative 10 makes 2x to the 6th. We have 6 times 2 times x to the second times x to the third, which is 12x to the 2 plus 3, or 12x to the fifth. We have 3 times 5 times x to the fourth, which is 15x to the 1 plus 4, or 15x to the fifth. And we combine their coefficients, which makes 27x to the fifth. 6 times 4 times x to the fifth times x to the second, which is 24x to the 5 plus 2, or 24x to the seventh, minus 2 times 12 times x to the third times x to the fourth, which is negative 24x to the 3 plus 4, which is negative 24x to the seventh. That gives you 0. That's a good one. That's a good one because a lot of students think that you get x to the seventh. That is not. You combine their coefficients, you get 0. You have no x to the sevenths left. So we have 3 times negative 2 times a to the fourth times a to the third, which is negative 6a to the 4 plus 3, negative 6a to the seventh. We have 2 times 1 times a to the second, a to the fifth, which is plus 2a to the 2 plus 5, which is plus 2a to the seventh. Negative 6 and positive 2 makes negative 4a to the seventh. 4 times 4 times y to the second times y, which is 16y to the 2 plus 1, or 16y to the third, minus 5 times 3 times y to the second times y, which is negative 15y to the 2 plus 1, negative 15y to the third. 16 minus 15 is 1, so you're left with y to the third. There you go. 3 videos in a lovely afternoon, even with a disruption. Good luck.